Hello everyone, welcome to the demo site of Smart Logistics production line. To my left is an area for smart manufacturing. To my right is an area for smart logistics. Today I will show you everything you need to know about smart factories. With hands-on operation, we can get a chance to see when the customer places an order, how are the raw materials processed in the smart factory so they can become products and then shipped to customer. This picture here indicates the floor plan of demo site of the smart manufacturing production line. In the back here, there are many processing machines and robotic arms. It's a flexible manufacturing system. To my right is a pickup area for warehousing. Here we use a warehouse management system to control AGV and CTU dispatch. The area at the left-hand side of the entrance is for smart logistics. This area features the technology of picking materials using electronic labels, which replaces manual work of material picking. Right now, the material is carried by AGV using a movable rack to the designated spot and then picked manually. Before we get to the demonstration, I want to give you an idea of the process. In my outline, there are a few topics. First is the overview of the smart factory. Next, the smart factory and operation management. Third, the smart logistics system. First, the micro overview of the smart factory. In a large-scale smart factory, it usually offers the following features. First, we can take a look at this picture. There is factory operation management, and then communication and network, smart manufacturing, packaging and logistics, and smart warehousing, basically the above categories. Here at the site, for smart manufacturing production lines, these features are also covered, including flexible manufacturing system, which is related to smart manufacturing. This is smart warehousing, smart logistics, intelligence system, communication and network, and factory operation management. Okay, the management structure of a smart factory is top-down, like a pyramid. At the top, there is the ERP system, Enterprise Resource Planning. ERP system, simply put, is a software for business or organizations to manage its day-to-day operation, which includes functions of HR, procurement, accounting, and supply chain management. So basically in charge of distribution. As to the second layer, it's the APS, Advanced Planning and Scheduling, and Manufacturing Execution System. Today the topic will focus on Manufacturing Execution System, MES. The third layer is supervision level. It consists of a few systems. The first one is MCS. MCS system. It's Materials Control System and Warehouse Management System. So basically, warehouse management system. This system, it usually will be connected with the data collection system. Below that is the control system, the PLC or the microprocessors. At the bottom it's the general equipment, like sensors or drivers. In terms of functions, the system functions and module planning, we have MES, WMS, and MCS. And features including put to light. The features are all listed here for your reference. For this part, we can do planning based on customers' needs. For the operation management of smart factories, there are three main themes. First is MES. As to MES, it begins from manufacturer order to dispatch of orders, establishing patches, staff dispatch, and reporting. All these steps. In the meantime, we also report the manufacturing history. As to project executions, there are some major functions, like production scheduling, work order management, and dispatch of production, entry and exit control of tasks, production history, machine utilization rate and task list, also data measurement and trend analysis, and distribution of processing time, and so on. Next, the MCS. As to MCS, I will show you an example. This is a material control system. Okay, it handles material control and order dispatch. Here, it's a punch system. The system monitors many sensors, including fuel, pressure, energy management, or vibration, noise, and temperature. Usually, in practice, it may use devices such as PDA or cell phones to connect to the network, so that the users can monitor the sensors and the status. The case here is a startup system. This is an example of startups. To the right, we can see it will use robotic arms to load and unload materials for processing and control the conveyor belt. Next is the WMS, Warehouse Management System. The example here is a hub for bicycles, a deburring system. It can also be controlled by, like I mentioned earlier, perhaps an app to load and unload materials, and material binding. To the right, you can see in the WMS interface the management of warehouse, or the status of the warehouse, and utilization rate. Below, you can see the work progress in the warehouse, and the status of machine and robotic arms. Okay, this one. Here's an example of MCS. Next, in the WMS system, you can see overview of the warehouse and programming of the picking station. Here's a schematic. It includes an AGV or CTU dispatch system. This is also monitored by WMS. The location of these AGVs and task execution can be displayed on the interface. Finally, the smart logistics system. The put-to-light picking system actually, an electronic label represents a customer with an order, which means an e-label represents one order. Today, we just need to check the display on AGV according to the display, and then place the material in the box for the order. When the box is full, it means I'm done picking. Then the system will send command to the e-label to light up the indicator and display. At the site, let's have a look. It's divided into a few sections. First is material picking. Second, packaging. Third, restocking. And then a standby area, we have movable racks. These movable racks are transported by AGV. To the restocking area. Or the picking area. As I said, the staff will follow the instruction on the screen, or the e-label, or projection, to place items in the box of the order, and confirm it on the e-label. Once it's confirmed, the packaging staff will package the items. If there's insufficient items on the rack, the system will automatically send AGV to the restocking area and have the staff to load the rack. This is the communication framework for the put-to-light system. It goes from Order Management System to WMS, then to WCS. As to WCS, it controls CAPS, Computer Aided Picking System. At the bottom, there's an RCS, Robotics Control System, in charge of vehicle and traffic control dispatch. As to the operation of put-to-light process, we mainly simulate the network system. When an order is placed, OMS will receive it, WMS will then transfer the goods. When my inventory is greater than order quantity, the system will confirm automatically whether we need to restock or pick material. If the inventory is below the order quantity, that means we have insufficient stock. We can either start producing or outsource the order. Below is the process of put-to-light picking. WMS will assign the CAPS for picking. The staff will pick the materials needed. After picking, we package and label the materials, and then write it off in the system. Here, we perform quality control of materials, and then we ship the products. In the process, we will be monitoring the packaging with CCTV. Here is the process of execution. Please refer to it for more details. Next is execution steps for put-to-light restocking. WMS will be assigning the tasks. If there is insufficient materials on the movable rack, it will first restock. Once the task is done, the rack will go back to the standby area or when there is another assignment. It will go to restocking area, then to picking area. Please refer to the area below for execution steps. Okay, for different section of the smart production line, I can give you a summary. In the middle section on top, it's the picking area. It will bind the materials and load it on the rack. On the right, it's the shipping area. For the warehouse, WMS is in control. It includes material preparation and automated storage, and shop floor automated storage, and then flexible manufacturing. For manual labor, after the programming binding, the material prepared for warehousing, CTU and AGV will deliver and transport the materials. Then the material will be sent to flexible manufacturing area for production. In the flexible manufacturing area, there is the 5-axis processing section. Among them, The robotic arm will load and unload the materials. The information will be fed to the upper system by EAP. In the middle, it's a module for smart manufacturing management, including MES and MCS and the NDIM system. On the upper right section, it's the put-to-light section. I just introduced put-to-light, packaging area, restocking area, etc. Today, I will demonstrate a process. We will simulate a situation when a customer places an order. It goes through the ERP system, Enterprise Resource Planning, to the MES. A work order will be generated. When the order is generated and material loaded, we will start the manufacturing. After that, product will be shipped. When shipping is done, it will be reported to the upper system. It will be reported to the ERP system for the shipment of product. For this section, I'll walk you through the steps. Like I said, when the customer places an order, how does the information flow so that the raw materials can go through the process in the smart factory and turn into finished goods and then shipped to the customers? In the smart factory, a system manages these materials. That's the WMS, Warehouse Management System. In the Warehouse Management System, on the interface, there are a few features. First is operation. Second is monitoring. Third is the statistics. Fourth is maintenance, and then system setting. In our system, a more relevant one is the picking and storage system. For this system, I'll give you a demonstration. But first, let's take a look at the section on the upper left side. It's a drawing that shows where the materials are located. It shows the information of trace. Below that is the programming history of the trace. All the history of the programmed binding, all of which is recorded here. To the right is the system for picking and storage. Here you can see workstation, the programming staff, number of trace, and the type of material. For the type of material, you could choose parts and processed products. Then we can do the binding. As to the quantity of the programming, it will be manually entered. You can enter the amount required. Next, for the materials, if you want to choose a particular section of the warehouse, you can designate a section, or if you don't make a choice, WMS can do it for you to designate a location. If I want to choose a location, I will click on a spot where the material is stored. The material location indicates the location of the rack in the warehouse. On the rack, it shows the tray information of each storage location for loading options. Let's go back to the main system. In the main system, other than picking and storage, there is delivery of finished products. The layout and interface is quite similar. Just on the upper left side, there is indicator for unprocessed, finished and abnormal states. In this system, during the processing of products, we will use measurement software in the machine. When the processing is done, any issues regarding the measurement or other problems will be displayed here. Then the staff handling the delivery of finished products can double check. For bottom left is the history of trade delivery. The interface on the right side, I'm sure you're all familiar. The only difference is that, besides finished products delivery, we also have raw materials delivery. When you click Finished Products Delivery, you can deliver finished products. As to the raw materials, in the next section, there will be introduction of raw materials loading and raw materials delivery. I will also give you a demonstration. To choose the section of the warehouse, if I choose delivery of finished products, the designated section will be on the left-hand side. The shop floor, the blue part, shows the products that are finished. As to the yellow part, this is yet to be processed. They are waiting to be processed. After I made the selection, for the delivery, the system will show the numbers for finished, disqualified, and unprocessed products. Then I can deliver finished products. Another important feature on the interface is the monitoring function. When we monitor the process, you get the overall picture. In this picture, you can see different status. As you see here, the front view in the picture is the layout of the warehouse. Let's say, if I click on this box on the left-hand side, then it will show the status of the material storage and shop floor storage. When we click on those, they will show information regarding the materials. It will be displayed here. Okay. If I only need to check the state of one particular material box, I can click on the block on the upper left side. This is for material storage. When you slide to the right, it shows shop floor status. The user can then choose with ease. Among different status, we use different colors to mark them. Yellow means waiting to be processed. The colors is an indicator. For example, if we have 19 yellow, that means 19 blocks are waiting to be processed. As to the ones being processed, it will give you a number. As to the ones that are finished, total finished products in the warehouse. Red means abnormal. After I introduced the interface, next we see the execution status of AGV and CTU when the AGV is in operation. For the lights below, above the AGV number, it shows a signal, so you will know clearly whether the AGV or CTU is loaded with trays and whether they are in operation. Let's switch back to the main screen. Besides monitoring the warehouse, we can check AGV status. Here it shows a dynamic image. All the vehicles in this site, whether you are in area for smart manufacturing or smart logistics, you can see all of them, the dynamic distribution of AGV and CTU. If a vehicle is dispatched for work, or if it's moving, then the icons will move when the vehicles move. We can also select one of them if I need to check a specific vehicle to see if it's idle or being dispatched and the battery power. You can see all the information on this interface. For this one, I selected AGV, and this is CTU. It will move about on the screen. Then we can see the current state of the vehicle and its battery power and coordination. Okay, next. What matters most in warehouse management is warehouse utilization rate. The WMS control panel shows us inventory status today. That is, materials moved in and out of storage, distribution of type of materials, and ratios of various status. They're all displayed in the warehouse utilization rate for the user's reference. In addition, the system has a tracking function that will track the movement of materials. Materials that are loaded, moved in, or moved out of storage. Whenever the materials are moved, the system is constantly tracking status of the materials. Okay. For each operation log, only persons who are authorized can access the messages. Let's go to Equipment Maintenance and open this maintenance log. The user can create a new maintenance task. We can choose a maintenance cycle, like monthly or regular maintenance, when creating a new maintenance task. Then the system will remind the user of the time the equipment should be checked. Now for troubleshooting. We may have to move some materials out of the storage. This may also happen when there is an inventory error. We will have to move materials out of storage. So we have designed the function here for the materials on a certain rack to be moved out of storage for inventory adjustment or reallocation. Lastly, the system keeps error reports, and we'll find a list of error reports here. You can select the reports you want to find by choosing the start and end dates. This is for the user to improve based on error reports. Back to the system setting. This is basic mode. And this is the type of material. In type of material, for the products we process, we can set up names of materials and information of the materials needed for binding here in the setting. This is all for the introduction of how WMS works. Next, I'll demonstrate how to program picking and storage. I will show you how to pick and move materials into storage. When we want to load materials on the rack, the staff will first load the materials into the boxes. When this is done, we'll program this information. In the system's picking and storage, choose the tray number. Then we can scan the barcode. Okay. Next, go to type of material. If I need car water tank parts, I'll choose it here. I'll program the information according to the actual amount. If the capacity is 12 boxes, I'll enter 12. Here we can choose if we want to assign a storage space. If I choose to assign a storage space, I have to do it manually. To pick a storage space, click on Assign Storage Space. We'll see which space is available. We could choose by clicking. For example, I'll choose this one. After I choose it, the system will assign it for storage. Next, click on Send AGV. The system will begin to program. But before that, we must move the tray of materials onto the AGV. Only then can we begin programming. Send AGV. We just use the WMS to move the materials into storage. Now we'll use the MES to choose the products to be processed today. The automation system will send AGV to retrieve the materials we just moved and send them to the assigned machine for processing. On the control panel, click on Import Work Order to create a new work order for today. Then choose a product for the automation system to process. Today we'll choose water tank parts. Next, we'll create a new batch for production. This work order tells us how many items will be made for this batch. And of course, it will also create a batch number. After we create a new batch, now let's go to Assignment Management. First, we assign task. We can choose equipment here. Equipment shown here can be assigned in the system. For the demonstration today, we can only choose CNC04. Click on Assign. Job assigned. This work order has selected products to be made and equipment to be used. Now we'll import it to this SCS to direct the automation system to control AGV and CTU to fetch the materials to assigned equipment for processing. Click on the green MCS production button on the display. A message will pop up to confirm the order is put to production. At this point, the CTU will go to the assigned storage space to pick the correct materials for the assigned products. It will send them to shop floor near the machine. Now the CTU is moving to the racks on which we just stored the materials. It is retrieving the materials. On the MCS control panel, we can see information about the work order in progress. MCS takes over the work order sent from MES. When MCS receives the order, it will give instructions to the assigned CTU to retrieve materials and send them to shop floor. As part of our automation system, once the materials are picked, the work pieces to be processed will be sent to shop floor near the machine into a storing space. Then another CTU will move to shop floor to fetch the stored materials and deliver them to an assigned machine for automation. So the CTU moves along a marked route to shop floor to fetch the materials placed by another CTU. The CTU will scan a QR code to verify the storing place before fetching the materials. Once the materials are fetched, they will be sent to a machine assigned by the MES, which is the CNC04 machine. The materials are placed on a material tray right next to the machine to be picked up by the robotic arm. When the products are completed, the MCS will give orders to instruct the CTU to fetch the tray that holds the products. It is now showing how the material tray is being placed onto the workstation next to the machine. The CTU has completed its assignment. Our CTU has successfully moved the products to be made and the tray to a rack next to the machine. For the robotic arm to follow up with automated processing. What I'll explain now is when our automation system has completed the production and place it onto the tray next to the machine. The MCS interface will show us that the products have been completed. We can then give an order to our automation system. There's a finish and return button that controls the tray we assigned earlier. When we click the button, a message will pop up and ask if the tray has finished its assignment. Click Yes to instruct the CTU to move the product tray back to the shop floor. Let's click Yes. The OK message pops up. This means the CTU has received our order. It will now move to the machine, retrieve the tray that holds the finished products, and carry it back to shop floor. Now the system has just dispatched a CTU. It's approaching the tray with finished products. It has picked up the tray. Now the CTU has completed the task. It will move back to shop floor near the machine and return to its designated place. As it carries out its mission, the shop floor will be filled by automated system with finished products. Then we'll use the WMS shipping system to ship the products. This is the full cycle of our automated procedures. From material storage, automated processing, to shipping the finished products. MCS, MES, and WNS, these three systems can handle processing, warehouse management to achieve automation. On the control interface, the completed tab shows us a list of completed work orders. We have now completed a work order. from processing to finishing and sending products to shop floor. What we'll show you here is that after products are finished and stored, the next step is shipping. On the control interface, click Shipping and choose the storing place to be shipped. Now, click Send AGV. Then the system will begin the procedure of shipping. The CTU has received the order and begun moving to the shop floor to retrieve the finished products from the shelf. Meanwhile, the shipping AGV that carries the trace jig will move to a pickup point and stand by. As we can see, the CTU has retrieved the products and is now moving to the pickup point. The automated guided vehicles are smart vehicles. It will automatically fine-tune its motions according to different situations and accurately align with the products and successfully complete the pickup. Okay, now the CTU has transferred the products to the AGV. The front shield AGV is now taking the products toward the shipping station. Okay, now our products have arrived at the shipping station. We're going to move the products onto the arrival area. Okay, next we're going to verify if the products at the shipping station match the information in our system to ensure correct shipment. So I'll scan the barcode. The system will verify the information of the products. Then click Confirm. The products are now ready to be shipped. Okay. Here we'll demonstrate Smart Logistics. With Smart Logistics, let's look at the system's control panel first. This is a put-to-light picking system. This function is linked to the rack on the left. This rack is different from traditional racks. It used to require human labor going to the warehouse with a list and pick the items, whereas now, with the booming of e-commerce, the service has become smarter. Okay, the smart AGV robot will go to the movable warehouse to pick up specific items and bring them to the picking station. As for the staff, they can follow the instructions on the screen and the e-labels and the projected guidance. They will be able to pick the items ordered by customers and complete the task. On the lower side of the racks are the e-labels. In a minute, we'll demonstrate. Before tasks begin, the system will show the quantity of the items and give light signals. As for the projected guidance, there is an overhead projector. The projector will guide the user to the correct storing place on the mobile racks to find the right items to be picked. Okay, now we'll demonstrate how the items are picked. First, the staff will put on a ring that functions as a barcode reader. So on the display above, he will initiate a picking task by importing the order information. Once the information is imported, our main system will dispatch vehicles to the mobile racks that store the order items. The AGV will move the racks to picking station. When the AGV arrives at the right spot, we will put down the mobile rack. Once the rack is on the floor, the system will show the items to be picked. The staff then follows the projection and retrieves the item from 3A. Then, he scans the barcode for the system to verify. And now, after he scans the barcode, the system will verify if it's the correct item. At this point, the staff takes the verified item, follows the info and quantity shown on e-labels, and puts it into the designated place. Now press confirm. The picking task is complete. When the picking is done, the AGV will return the mobile rack to the standby area. Now we've come to the back, behind the storage racks. This is the collection area, where the items are packaged before shipping. We've just picked the order items. Once the picking task is complete, the light signal here and the buzzer will both turn on. Next, we'll signal the person in charge of packaging to go to the place where the lights are on. Take the item that was picked and press Confirm. At this point, after the item was picked, we will begin to package the item. Now, the task of packaging has been completed for the goods. Next, let's come to this area where racks are restocked. My colleague will demonstrate how restocking is done. On the System Control panel, simply click on the items to be restocked. Choose Restock and confirm. Now the system will select the item and assign the mobile rack and send it to the restocking area. Follow the instructions on the panel and scan the barcode on the item. Press Confirm. Put the item into the designated place. It's done. The restocking task is complete. The AGV will move the restocked rack to the standby area. This is how restocking is done.